Good afternoon, everyone. Let us start our afternoon event with a short prayer. Dear Heavenly Father, we thank you for gathering all of us today in this important CHIRM webinar event. May you bestow your guidance and blessings on this event so that we may be able to appreciate its significance in our lives. Bless our speakers and everyone present today that each may be able to share and apply what they have for your greater glory and honor. We also pray that you guide and protect us and our families from the upcoming Typhoon Ulysses and continue to protect us from the COVID-19 pandemic. Let us offer a brief moment of silence for our other personal prayers. Amen. Good afternoon, everyone. Welcome back to our Center for Hazard and Environmental Resource Mapping activities for the Pre-National Science and Technology Week 2020 celebration. The theme of this year's NSTW is Agham at Teknolohiya, Sandigan ng Kalusugan, Kabuhayan, Kaayusan at Kinabukasan. Throughout the NSTW, these four thematic sectors will be highlighted through virtual presentations or walkthroughs of exhibits, centers, laboratories on a digital platform. Due to the ongoing public health concern brought about by the COVID-19 pandemic, all NSTW-related activities will be conducted virtually this year. So we hope you will get to learn something new from our webinar while in the safety of our homes or gadgets as we practice social distancing. By the way, if you have just recently joined our Zoom meeting or our Facebook live stream, I am Rafael San Antonio and I will still be your host for this afternoon. Earlier this morning, we have had our launching of the CHIRM AVP and the ceremonial turnover of maps to the Taal affected LGUs. For this afternoon, our highlight activity is the CHIRM webinar on appreciation of disaster risk reduction and management, DRRM maps. As we have previously mentioned, this activity aims to strengthen the collaborative efforts of mapping agencies and stakeholders in the provision of authoritative geospatial data, information, and services. It also aims to capacitate LGUs, SUCs, line agencies, and other interested individuals or groups on utilization of geospatial data and to promote the CHIRM laboratory and its services to interested groups and the general public. Now, without further ado, since I think it's already starting to, the storm is already starting to be felt by our neighboring areas, let us begin with our first resource speaker. Our first research our first speaker is a researcher in the DOST's Advanced Science and Technology Institute for Space Application and Mapping. He is a licensed geodetic engineer who has been in research and development sector since 2013. He is the tech lead of the DATOS project, which specializes in artificial intelligence and machine learning applications of space technologies. Please give a warm welcome to Engineer Roel M. De La Cruz.
Hello, good afternoon, everyone. Good afternoon to the participants. I would like to share my screen. Please enable it. Thank you. So, by the way, I will be discussing about the AI for mapping that we are pushing here in the OST. It's artificial intelligence application for mapping. So most of the data sets that we'll be using are from space data. So they are from satellite imageries. So okay. So in DOST, we have this what we call SNT infrastructure. Uh, they consist of different infra. First is the PregiNet or our educational and government network. That's the original name. We can say that we have fast internet connection that enables the transfer of large data sets, especially for the satellite imageries. So some government agencies are already connected with this. You can go as much as 1 gigabyte per second, or a little very near to that. And in ASTI, we also have the PEDRO, or the Philippine Earth Data Resource and Observation Center. It's our ground receiving station. So they control our Diwata satellite. They also receive and send commands to some other satellites that we have subscription to, commercial satellites. And soon they will also be able to do the same with the Novasar satellite. Novasar is a SAR satellite. Maybe I can discuss somehow a little bit about it later on. Uh, we are a part owner of the Novasar satellite, and to do the processing, we have the core facility, computing and archiving research environment. Okay, so it's a super computer, or HPC, that we use to process our data sets. And the DOST also implemented the Datos project. It's an R&D project funded by PSHERD, ended last February 2020, this year only. And since then, we're continuing the applications that was developed by the Datos project, and sharing them with everyone, with government agencies, and also they're free for government agencies. And also we are training SUCs on how to use those technologies. So I will be presenting the outputs in this presentation. Okay. Aside from that, we also have our friends from Stamina for Space program. It's the original PHL Microsat program, and those groups will be transitioned to the Philippine Space Agency later on. Actually, the transition is ongoing as we speak. So I would like to start with posting the question, like, why is a country like the Philippines going to space? Okay? So we're going to space kasi 'di ba, there are other people that saying na magastos 'yan, bakit din na lang natin ibigay directly sa mga tao, etc. But if we look at in the bigger picture, mas malaki yung magagain natin in this type of endeavor. We are going to space because we need data. Data that enables scientific discovery. Siyempre, paano natin maintindihan yung environment natin? And siyempre, pag nasa space tayo, mas malaki yung nakukuha natin na dataset. So, sa mga scientists natin, mas malaki yung naaaral nila na data to create solutions and to help din in decision making. Of course, kasunod nun is yung evidence-based policies na mga gawa natin dahil dun sa mga pag-analyze ng mga datasets na yon. And uh, to improve our economy, to become a knowledge-based one, okay, to foster inclusive growth. So I'm seeing various participants from the DRRM, and from the planning divisions of some LGUs here. So maybe this is you can understand better what I'm trying to say here. And of course, tackling information poverty. So there's a challenge for everyone in DRR actually. We need rapid map generation during for disaster response and monitoring. So if you look at this picture in the background, this is a very large data set actually. It consists of the whole of Central Luzon. So we need to create map that fast. As a backgrounder, there are one-third of operational Earth observation satellites, of satellites in space are Earth observation rather. Okay? So there are thousands of them. Tapos, sorry, my stats is 2 years old. Nung 2018, 684 of them are looking at the Earth. Okay? So either kumukuha sila ng picture na high resolution, or they're looking at the atmosphere, or they're looking at the oceans, or they're looking at the temperature of the Earth. So hundreds of satellites yung nakatingin sa mundo observing the Earth. So ganun kadami yung satellites na nakatingin, and of course correspondingly ganun din kadami yung dataset na napoproduce. So si NASA alone, they have 9 petabytes of EO data. Okay, so naka-distribute yan sa different data centers nila across the US. So ganun karami yung dataset na pwede nating magamit. Ngayon, sa Pilipinas, we also have those datasets. For example, sa Pedro Center, they have terabytes, na tens of terabytes of data, satellite imagery sa Pilipinas. So some of them are very high resolution. And sa datos alone, actually, medyo luma na rin tong stats ko. I think nasa mga 80 terabytes na yan by February. And continuously, we are also gathering data sets from free sources like Landsat, Sentinel satellites from the European Space Agency. So madami tayong datasets, terabytes of them. Okay? So pero usual na problema natin, we don't have a good inventory. So ginawa namin example dito are the coconut trees. So we know since nasa region 4A tayo, I assume na marami tayong nyog dito. Maybe we have an estimate kung gaano kadami yung nyog natin. Pero pag bumabagyo, nung nakaraan dumaan si Rolly, and as we speak, nandyan na, nararamdaman na natin si, nakalimutan kong pangalan. Anyway, so kapag dumaan yung bagyo, maraming nasisira dyan, and we can't update our inventory that fast. And if we do so, it will take us years and tens of people to do field validation and to do the mapping and update our inventory. So expensive siya, highly technical, and labor intensive. That's why we are proposing a solution, okay, using data science and artificial intelligence. So, ito lang, the illustration dito sa slides in the differences. Actually, parang Venn diagram yan. Yung data science, they cater with big data and they use artificial intelligence. Sa loob ng artificial intelligence, marami pang classifications ng AI. So, depende sa gusto mong gamitin. What we will be discussing dito na methodology is yung deep learning. So, isang maliit na aspeto ng artificial intelligence, malaking field po kasi siya. Okay? So to do this, ito yung group na kailangan or na at least sa amin na composition ng team para magawa ito. So of course we need the programmers for the AI and scripting. We need the remote sensing experts para interpret yung terabytes of imagery natin. Para syempre kung walang mag-analyze yan, wala din tayong mapapakinabangan. So the difference is the remote sensing people, they know how yung sensors na dala-dala ng bawat satellite sa space ay nagbe-behave. So they can say actually na okay, kung itong sensor na to ganito yung behavior ng itong satellite image na to, ganito yung behavior ng sensor niyan, so ganito dapat yung gawin natin para ma-extract natin yung information na gusto natin. So yun yung ginagawa ng mga remote sensing experts. And the GIS experts to do the mapping, okay, application nito. Okay, they do the overlay analysis, all of those geospatial analysis na nanggagaling doon sa output ng mga remote sensing experts natin. Now, ito na yung naging output based from that. So, given itong mga data providers na to, yung Pedro, yung European Space Agency, yung ESGS, kapag may mga disaster, nagbibigay din yung mga ibang group from Sentinel Asia. We also have geospatial datasets before from NOAA, from Field LiDAR program. We have datasets from the government, from MGB, from NAMRIA, from FIVOX, and mayroon din tayong mga datasets galing sa mga social media. So lahat ng yun ay pwede nating i-mix up to produce yung mga analysis na gusto natin. So in this slide, from a satellite image tulad nung nandito sa kaliwa, okay, yan yung typical na alam natin na itsura ng satellite image, is a true color imagery. So kung ano nakikita natin, we can process those datasets using yung core facility para gawin yung nasa kanan. Yung nasa upper right ng slide na to, that's a false color composite para ma-highlight kung nasan yung mga landslide area. Yung nandun naman sa kanan sa baba, yan ay output ng AI nung pina-extract yung built-up area sa Apari Cagayan. So, you don't have to digitize that. Okay? Kung na-train mo enough yung AI, which is we will discuss, ay siya na bahala na gumawa niyan. So, train now and mag-ani ka later. So, maghirap ka ngayon para maginhawa ka bukas. Parang ganun yung idea nito. Okay? So, yung processing ay hinati namin into two, object detection or segmentation. So, dalawa po yung object natin. Pero for simplicity, tawagin natin na object detection. And the time series analysis. So, yung HPC na nakikita nyo dyan, that's sa loob ng high performance computing facility siya ginagawa to produce our maps. Okay? So, dun muna tayo sa object detection. In object detection, bumalik tayo nung bata tayo. So, gusto ko lang i-illustrate kung paano siya nag-work. So, ito, alam natin na this is picture of a cat. Okay? So, paano natin natutunan na kapag tiningnan natin yan using our naked eye, ay alam natin na pusa siya. Okay? So, kasi nung bata tayo, ay binigyan tayo ng sobrang daming picture ng pusa or pinakita sa atin or binigyan ka ng picture sa book or kung saan man or nakita mo sa paligid mo na, yun, pusa yun. So, eventually, na-train yung utak mo na kapag nakita siya ng ganyang form, ganyang kulay, ganyang texture, and everything, ay malamang pusa yan. So, ganun din yung sa aso, di ba? Pag tinuturuan natin yung mga anak nating bata, mga 1 or less years old, di ba? Yung mga forms ng elephant, dogs, cats, monkeys, etc. So, kapag nasanay sila, pag madami na silang nakuha na picture or visual cues ng isang object na gusto nilang i-identify, then natututo sila. So, ganun yung gusto natin na i-emulate. Okay? So, yung ginagamit natin dito is yung tinatawag na artificial neural network. So, syempre, since neural network siya, ang tinatry natin na i-emulate dito is yung ating, kung paano nag-work yung mga neurons natin sa brain. So, meron tayong input signal, mag-fire yung mga series of neurons para interpret natin yung image later on. Of course, malayong-malayo yung computer, yung AI natin, sa totoong capacity ng brain and how it does things. So, sobrang maliit na bagay yon. Maybe baka isang patak lang yun sa drum ng tubig, for example. Pero at least nagagamit natin yung same concept para i-apply sa processing natin. So there are billions of neurons doon. So nilalatag natin yung mga neurons na ganyan sa ganitong paraan. Yung mga bilog na yan, isipin nyo na yan ay mga neurons, okay, na pa isa-isa. Then may mga input ka and then may mga connections yan, yung mga lines na nakikita nyo na magfa-fire, di ba? Pag nag-interpret ka ng isang bagay using your brain, may mga series of neurons na nagfa-fire, okay, para tumulong sa'yo. So ganun din yan, para hanggang umabot sa dulo. Of course, that's purely mathematical with equation and everything. Okay? So you can study more about it kung paano siya ayusin. Okay? Pero let the computer do that or let the software do that for you. Okay? Okay? So yun yung concept na ina-apply natin sa object detection. So yung workflow actually is very simplified. Mag-process ka ng data, okay? Geometric calibration, geometric correction, etc. Yung mga typical na remote sensing processes natin. And then you interpret and then you create a training data, di ba? Para matutukan na mag-identify ng pusa, kailangan mo ng maraming picture ng pusa, di ba? So kung gusto mo mag-identify ng coconut, bigyan mo yung kumuha ka ng maraming picture ng coconut at i-feed sa isang neural network hanggang matutunan niya na ganun yung itsura ng coconut and so on. Okay? So ang key dito, kung ikaw, personally, ay tumingin sa satellite image, halimbawa sa Google Earth, nagtingin-tingin ka, kung kaya mong i-identify yung isang object sa satellite image, then kaya mong turuan yung AI para para i-identify niya yung object na yun for you. So yun yung concept. Pero pag ikaw tumingin ka sa satellite image at hindi mo alam kung alin dun yung gusto mong hanapin, I mean, hindi mo ma-distinguish yung object na hinahanap mo, then may hirapan ka. Kasi paano mo naman tuturuan yung AI model kung ikaw mismo ay hindi mo alam kung ano yung hinahanap mo. So yun yung main idea dito. Okay? So kapag meron ka ng training data, you train the AI model and then you do validation, typical of a mapping activity. Right? So, these are the list of AI models na may prototypes yung Datos project. Some of these are hindi na prototype. So, depende sa klase ng satellite image na gagamitin ay may na-develop na AI model using the technologies na na-discuss ko a while ago. So, sa very high resolution, na 0.3 meter resolution na satellite image, ibig sabihin, roughly, ang isang pixel ay katumbas nun ay 0.3 meters sa ground. Okay? So, you can translate resolution na parang ganun. Okay? Yung spatial resolution. So, kaya mo nang mag-identify dyan ng mga individual objects tulad ng nakikita nyo sa Google Earth. Okay? Pwede mo nang extract yung mango trees, coconut trees, pili trees, buildings, etc. Lahat ng kaya mong makita sa isang high resolution, very high resolution na image. So, yung mango and coconut dito ay hindi na prototype. Production ready na iyan. Okay? Doon naman sa planet imagery, so magkakaibang satellite imagery ito, ano, na 3-meter resolution, ganun din, medyo mas hindi na ganun ka sharp yung image natin. So yung mga nasa screenshots na yan, these are actual resolution ng imagery. So mas generic na rin yung kaya mong i-extract kasi hindi mo na, although parang nakikita mo na maraming building yan, pero hindi mo na kayang i-identify individually yung mga buildings diyan. That's why ang kaya lang nating ma-extract ay built-up areas, mga water bodies, vegetation, yung road, madali siyang makita, etc. So, kung mapapansin nyo, medyo mas nagiging generalized na yung na-extract na object. So, you go to the Landsat image, that's 30-meter resolution, so mas generic na yung na-extract. And dun sa pinakadulo, that's synthetic aperture radar. So, magkaiba. Lahat ng tatlong nauna dito ay mga optical. Kumbaga, yung typical na camera natin, kumuha ka ng picture. Okay, so ganun yung paraan ng pagkakuha nitong naunang tatlo. Yung nandun sa kanan, radar yung ginamit. Yung sensor na dala-dala ng satellite ay nag-send ng sarili niyang signal, microwave signal actually. Tapos, minimeasure niya yung bumalik na microwave signal dun sa sensor. So, sideways. Kaya ganyan yung itsura niya. Dun sa mga matitigas na bagay or dun sa mga rough surfaces, depende sa orientation, medyo mas maliwanag yung bumalik na signal. Kapag nag-reflect away yung sinend niya na microwave signal, wala nang nakakabalik masyado sa sensor, nagiging dark siya. So, sa mga smooth surfaces tulad ng tubig. So, mapapansin nyo dyan, doon sa mga water bodies, medyo dark yung itsura niya doon. So, yun yung uh, layman's explanation ng difference nung optical and SAR imagery natin. Okay? So, punta naman tayo sa time series analysis. So, sa time series, ang ginamit namin dito is voice recognition. Yung time series kasi, yung mga satellite kasi natin, usually fixed yan, yung orbit niyan. So, alam natin na every several days, or every 12 days, or every 15 days, depende sa revisit time niya, ay dumadaan siya sa same spot. Okay? So, every 15 days, for example, or every 12 days na lang, meron kang bagong data sa same lugar. Then, after 12 days, may bago ka na namang data sa same na lugar. So, technically, pwede mong i-analyze yung temporal na behavior ng lugar. So, yun naman yung ginamit dito. So, yung concept ng voice recognition is dun sa mga cellphone nyo, pag nagdi-dictate kayo, pag sinabi mong hello, so ita-type niya yun na hello, pero pag sinabi mo na hello ng mas mahaba, tina-type pa rin niya yun na hello. So, meron siyang specific na signature, temporal signature na tinitingnan para interpret na yun yung word na sinabi mo. Ay, tapos yung paraan ng pag hanap nung signature na yon, in-apply namin sa satellite imagery. Okay? So, for example, ito yung visualization ng satellite imagery mo, no, every pixel of it na maraming beses dumaan sa isang lugar. So, kung meron kang so bawat pixel niyan may makikita ka na pagbabago. So ito ginagamit namin to sa radar. So analyzing yung backscatter values. So minsan malakas, minsan humihina. So through time, titingnan mo yung behavior. Ngayon, kung meron kang template na signature, for example, yung nandun sa taas, this is a template signature of a sugarcane plantation. So, mula nung nagtanim hanggang nung mag-ani. So, kung meron kang template na signature ng isang seasonal na bagay, pwede mong hanapin sa stock ng imagery mo yung signature na yan using yung voice recognition method. Okay? So, same concept din yung paggawa, ipaprocess mo yung data kasi SAR siya, medyo mas mabigat siya kaysa typical na optical imagery. Maghanap ka ng temporal pattern. Halimbawa, gusto mo maghanap ng plantasyon ng palay, corn, rice, so anything na seasonal crop, theoretically. Then, yung sigurado ka, then kunin mo yung temporal pattern doon, then gamitin mo yun as template at hanapin sa the rest of the satellite image kung asan yung mga may ganung katulad na temporal signature. So, ganun yung concept kung paano siya nag-work. Okay? Now, let's go to the application of the two methods na na-discuss ko. So, itong road network prediction, actually, ito yung pinaka-baby namin nung tinesting namin kung paano natututo yung AI. So, habang tinitrain mo siya, habang inaayos mo yung training niya, mas gumagaling siya. Okay? The same technique is being used by the Project Dime ng DBM para i-monitor yung mga farm to market roads natin. So since we have temporal data set, this one is from planet. So nakikita mo. So hindi mo na pwedeng sabihin ngayon sa government na tapos na namin 'yun, pero sa totoo hindi pa kasi nakikita na the people are already using satellite imagery para tingnan kung totoo nga ba yung nire-report mo. And ang maganda din doon, they're using artificial intelligence to help them analyze those images. Okay? So, ito naman, flood situation mapping, ito yung regular na pinoproduce ng Datos team dito sa ASTI. So, using radar, temporal, kapag matuyo yung isang bagay, usually medyo mas malakas yung backscatter. Pag nagiging basa siya, I mean, nagkakaroon ng water sa ibabaw ng lugar, mas nagiging smooth siya. So, mas bumababa yung nare-receive na backscatter signal ng radar. So, nagkakaroon ng drop. So, we're using 3 dito, dalawang before, isang after. So, titingnan namin lahat yan kung meron bang nag-drop ng backscatter that signifies presence of water. Kapag ganun, minamarkahan siya as flood. Okay, so yung AI na rin yung gumagawa nun. So, we can do yung ganyan kadaming flood maps in just a few hours, 1 or 2 hours lang meron na tayong flood map na ganyan kadami at 10-meter resolution. Okay? So, ayan. And we also tried doing it, tinuruan namin using dataset ng Marawi para mag-detect ng damage areas. Okay? So, medyo okay naman siya. This is a prototype actually. Isa sa mga DR applications nito is yung nangyari sa Benguet last time. So, maganda din sa mga if you request satellite imagery ng isang disaster event sa ASTI, for example, sabihin nyo kung asan siya, ano yung coordinates niya para mas marami. Kasi sa dami nung, di ba sabi ko kanina, there are terabytes of satellite imagery dito. Kung sabihin mo lang na pahingi po ng satellite imagery ng landslide sa ganitong lugar, so hindi namin alam kung saan yun. So kung sabihin nyo na ito po yung coordinates, pahingi po ng imagery dyan, then we can provide. So nangyari kasi ito sa Itogon last year. Okay. So, ang ginawa namin, since hindi namin alam kung nasaan yung landslide, so we processed the satellite image, nagpatakbo kami ng road network, tapos dun sa bagong image na capture, nagpatakbo rin kami ng road network. Napansin namin na may nawalang kalsada. Okay? So, hindi na na-detect ng AI itong nandito sa part na to. Actually, hazy nga yung imagery. And we also process yung built-up area dun sa lugar. So, kung makikita nyo dun sa loob ng landslide area, meron ngang mga structures doon. Okay? As nakikita nyo dito sa satellite image na ito. Okay? So usually, yung a few tens of square kilometers, it will just take around 2 minutes para gawin ng AI yung mapping. Okay? Another example is yung sa mga series of earthquakes last year sa Cotabato, sa Makilala. So nagkaroon ng mga landslide. So, ang ginawa, since nasabi ko kanina na may land cover AI, dinetect namin yung mga vegetated areas. Tapos, after nun, dun sa after image, tingnan namin. So, yung mga from vegetated, tapos suddenly naging built up, yun yung mga in-interpret namin as possible na landslide occurrences. So, mabilis yung mapping. So, kung ikaw pupunta ka sa bundok para hanapin yung mga ganitong klase ng bagay at i-delineate yung extents nila, it will take you months or so. So, yun yung sinasabi ko kanina. Pero, if you already have a model trained at may nakuhang capture ng satellite imagery na wala masyadong ulap, you can do that in just a few minutes. Okay? This is not an AI pero an illustration ng drought monitoring. Okay. Sa agriculture naman, so ito yung ano kanina, result ng temporal. We can map sugarcane, rice and corn. So yun pa lang doon pa lang namin siya na test. Okay? So kung may gustong mag-test sa ibang seasonal crops, pwede tayong mag-usap actually. Okay? So tingnan niyo itong image na to, ito yung illustration kung anong itsura ng mga bagay-bagay na related sa fisheries sa radar. Okay? So, yung mga fish pens, fish cages, tapos yung mga fish ponds. So, using that, madali kasing makita yung mga fish ponds sa radar. Since side looking siya, sa optical kasi, minsan nagiging kakulay na niya yung water body, so hindi masyadong makita. Pero dito, nagiging mas maliwanag siya. So we also did mapping ng mga fish pen sa Laguna Lake. Sorry. I think, saan ba ito? Hindi ko maalala kung saan ito. I think sa Pangasinan. Ito naman, si AI na yung nag-digitize ng lahat ng nakikita nyo na may kulay dyan. Okay? Yung fish traps, fish ponds, fish pens sa Bolinao. So ito, actually, we created the prototype, tapos dinevelop further together with the Philippine Statistics Authority because we have a memorandum of agreement with them. They will use AI for the census of agriculture and fisheries sa 2022. So by 2023, gagawin nila yung census nung 2022 na agriculture and fisheries natin, at hindi na sila table, okay? As before. So ang mangyayari is magkakaroon na ng mapping talaga. So they will do this nationwide. So yun yung pinagkakabisihan right now. So yeah, that will be the largest mapping using AI kung ma-pull off namin ito by 2023 actually. Okay? So maybe itong coconut na to, nakita nyo kanina sa slides ng term kaninang umaga. Actually, ang ano lang dito is using this image na training, pinapredict namin yung kabila. So sobrang dali niyang gawin. Okay? So if we just want to map or count the coconuts, madali siya. Actually, this one is mabilis na, pero mas pinabilis pa lalo ngayon. Oops, I think may kulang akong slides. So, ayan, coconut din pala ito. We also did yung bilog, yung itsura niya, and ito, yung mas mabilis ngayon, binabox na lang siya. Kasi hindi naman natin kailangan i-digitize yung itsura ng coconut. Kailangan lang nating malaman kung asan siya, at kailangan siyang bilangin. So, ganito na lang yung ginagawa ngayon. So, mas mabilis na siya kaysa dun sa previous na nakita niya. Hindi na rin ito prototype, production ready na rin siya. Validated na rin yan ng Philippine Statistics Authority. Ganun din yung sa mango trees, hindi na rin ito prototype. Okay? This one is for detection ng pili. Trinay lang namin. It's not that perfect. So, medyo mahirap pakita yung pili sa satellite imagery. Okay? So, yun yung mga ibang application. And yung land cover, saka yung change detection. So, we already have yung level 1 land cover classification from Landsat. So, ganito yung itsura niya, yung mga bears. So, pinagsama na namin lahat ng mga vegetation, minerge namin yung mga agricultural and hidden slowdowns dyan. From Planet naman, we can also do this, okay, from the satellite imagery dito sa left, we can extract yung land cover niya tulad nung nandun sa right. Okay, so again, level 1 ulit, yung mga basic na land cover. And if we go through time using Landsat, pwede nating tingnan kung ano yung sprawl, urban sprawl, for example, sa isang lugar or any type of land cover, pwede niyo check yung changes kung lumawak ba or umikli ba, etc. And dun sa mga nagmo-model na kasama natin ng mga researchers, they can do some modeling and somehow they can project in the future what this place looks like in 50 years from now, 20, 30 years from now. So, yun yung mga nagagawa nito. Actually, medyo mahalaga siya lalo na sa planning. Okay? So, what can we use this technology for? Okay? So, madami actually. Yung original na pangalan nito kasi is AI for EO, but we rebranded into AI for mapping. So, maraming thematic areas na pwedeng gumamit. You can use it in infrastructure, in monitoring, in food security, defense and security, DRRCCA. So yung mga thematic areas na yon, may mga agencies na tayo na nandiyan. So yung mga LGUs natin, yung mga government agencies, etc. Okay? So yung mga government agencies na yon, they can use these AI models nandito sa left and right to do their mandates. Okay? So kung gusto niyo maghanap ng flood maps, earthquake damages, etc., road detection, and so on. So may mga pwedeng gumamit. And DOST-AST is open for government agencies who want to collaborate kung paano nila gamitin ito to detect something, to do their mapping activities. Okay? So, ayun. So, moving forward, wala akong diniscuss na equation or whatsoever. Pero this kind of endeavor is mathematically extensive, saka programming intensive. Pero to make things easy, ginawa na namin siyang software. Okay? Wala nang ang gagawin niyo na lang is uh, turuan namin kayo paano gumawa ng maraming training data, di ba? Ilagay mo sa isang folder, click mo kung nasaan siya nakalagay, and bahala na yung software ito na gawin yung internals, kung anong equation yung gagamitin niya, etc. etc. Okay? Gaano kalaking batch, ilang beses, gaano yung learning rate, etc. Yung mga ganong bagay, siya na bahala. Okay? And kapag na-train mo na siya, after mga siguro 24 hours or 8 hours minimum, pwede mo na siyang gamitin para mag-predict sa isang lugar. Halimbawa, nag-train ka ng AI para sa mangga. Pag may enough na training data ka na, i-train mo siya using yung screenshot na nandun sa kabila, this one. And after, pag tulog mo, pagising mo sa umaga, pumunta ka sa isang lugar, na-train na niya yung AI model, hanapin mo yung model, bibigay mo kung asan yung satellite image, saan niya ilalagay yung output, then wala, after 2 minutes, meron ka ng mapa. So, ganun na siya kabilis. So, we are conducting, last year, actually, we conducted several batch ng training ng AI for EO. So, para maipakalat yung paggamit nito. Actually, ang goal dito is maipakalat yung technology such that tayo sa Pilipinas will be the first anywhere na AI-enabled sa mapping. Okay, so yun yung goal kung bakit natin ginagawa to. Nasa slides ko pala. We want to accelerate yung transition to AI-enabled mapping ng lahat. Okay? So maganda yan kung mag-translate into the industry. Okay? So yun yung vision and mission kung bakit ginagawa yung ganitong klase ng technology. Okay? So if you need help or you want clarification, you may ask siguro or you can contact us dun sa mga nandito. Okay, thank you very much.
Thank you very much, Engineer Roel, for your very informative presentation on AI for mapping. Grabe, ang galing ng artificial intelligence. Gusto ko yung sinasabi ni Sir na tinetraining yung AI ng human para mag-identify or magbilang ng mga objects. Pero na-curious tuloy ako if possible ba na sa future ay mas magiging matalino yung AI kesa sa tao. So,
Anyway, sagutin ko. Actually, sa ngayon, mas matalino siya na siya kaysa sa amin. Sa pag-extract ng features. Pero wala pa naman siyang reasoning something. So malayo pa naman siguro tayo doon. Thank you.
Thank you, sir. For those with questions and insights, please just message using our chat, and we will be answering or sharing those later in our open forum. Now, let us proceed with our second speaker. She is the supervising science research specialist and project head of GeoRisk of the Philippine Institute of Volcanology and Seismology. Please give a warm welcome to Ms. Maybelline P. Kahulugan.
Hi, everyone. Okay, good afternoon, everyone. I'm Mabeline Kahulugan, and hindi ko po Hindi ko makita yung participants, pero nakita ko po sa program na nandito po si Ma'am Dorothy. Hi, Ma'am Dorothy. And hello, everyone. So today I will be discussing the GRIS Philippines initiative, and we'll also be discussing the platforms that the initiative has developed. So the vision of GRIS Philippines is to be the Philippines central source of information for accurate and efficient hazards and risk assessment. We formulated this. We recognize the importance of having a centralized source of information so that we can ultimately help the government increase its resilience to natural hazards. So if you would notice, all the platforms of GRIS Philippines has this logo of GRIS, which just shows us the database system that was created and as well as the methods employed, and everything is um, geo- in geospace. Okay, so it's geographically located, and everything can be represented on maps. So what is the GRIS Philippines initiative? We can actually consider it as a whole of government ICT platform. And this is a multi-agency initiative. So it just so happened that DOST PVOLX is the one leading it, but actually it's being supported, and the data that are being utilized in the system come from various government agencies. So as a platform, no, because we have collaborations among different government agencies, so we can consider this actually as a governance platform where we can serve multiple stakeholders. And as a physical platform, we can look at it as a platform that would integrate data and as well as would provide methods and tools that could analyze information for hazards and risk assessment. So these are the platforms that were officially launched under the GRISC initiative. So we have for data collection, it is called the GeoMapper PH application. It comes as a web application as well as a mobile. It is being governed by credentials, and it can be used prior to disasters, during or after a disaster, since it is a GIS-based platform. Now, for analytical platforms for hazards and risk analysis, we have developed two platforms, namely GeoAnalytics PH and as well as the Hazard Hunter PH. These platforms are publicly available. So, ibig sabihin po, and anyone can use the the platforms, no, be it individual or NGA or LGU. So the integrated system has government data in it, especially those information necessary for risk assessment. So for now, we have information from PVOLX, from Pag-asa, MGB. We also have information from DepEd, DOH, and for the base maps as well as for the beneficiaries. No, we have NAMRIA and as well as OCD. Now, DPWH as well as DTI also contributed information already into the database, and we have platforms or dashboards for them already, and as well as data from the PSA. So if you see here the flow of information, so from the different government agencies, all those information would be feeding the GRIS database and servers. And then there's also an arrow going to the different organizations or different agencies that would eventually consume the information. Now, those that are publicly available information can be forwarded to the different publicly available systems like the Hazard Hunter and the Geoanalytics, and then these will be um, then consumed or used by the public for analysis. But before we proceed, I would like to just show you the timeline. Now, since GRIS Philippines is really not an overnight initiative, it took decades or more than a decade to really collaborate with these agencies, especially those agencies involved in hazards mapping and as well as for the dissemination of DRR related information. So it took us about 15 years to develop that kind of relationship and as well as the working relationship that we were able to attain through the years. That's why GRISC was made possible. Okay, so let me show you the history of the working relationships of the different agencies. So in 2005, we had the RENA project. So RENA project was for the LGUs of Real, Infanta, and uh, General Nakar. Here, DOST, PHIVOLCS, Pag-asa, MGB, OCD, and LGUs, not mentioned, yung RENA LGUs, collaborated to conduct hazards mapping in those areas and as well as conduct IECs or information, education, communication campaigns. So we have here the logos of the different agencies, and we also have the funding agency's logo here. Okay, here are some photos of the hazards mapping conducted as early as 2005, where we collaborated with other agencies. Even during information dissemination, lahat po ng mga ahensyang iyon, lahat ng mga representatives from the agencies go to the different LGUs. So we see here personnel from PHIVOLCS and the personnel from Pag-asa all doing the same thing, teaching the LGUs the use of the hazard maps. So we also see here LGU representatives being taught how to use the hazard maps for assessment. So this is as early as 2005. Now come 2006 up to 2013, we again worked together since the result of the RENA project was a success and it was a good collaboration indeed. So the government agencies again worked together to form the READY project. So ang ibig sabihin po ng READY project ay hazards mapping and assessment for effective community-based disaster risk management. And you would see here the different agencies involved. So we have OCD, we have PHIVOLCS, we have the Mines and Geosciences Bureau, NAMRIA, Pag-asa. Again, the funding agency is also represented here. So let me show you some of the photos of hazard mapping conducted from 2006 to 2013. And during those times, we actually go together to the field, no? And you see here, this is Sir Oka from Pag-asa and some of the people staff. We all work together and we help each other, even during mapping and as well as during information dissemination. All those information are being um, collated by NAMRIA and produce these kinds of hazard maps. So I'm showing you here the result of the hazard mapping conducted in Laguna under the READY project, and this is the Banahaw Volcanic Complex. So you would see the different hazards and as well as the different scales of mapping. So this, for example, is provincial scale, and then we also have municipal scale hazard maps formulated or developed for the specific municipality. So as early as 2006, we've been doing that, and as well as really go to the LGUs to cascade the results of the mapping. Approximately between 2012 to 2014, a GMMA risk analysis project was also um, developed or established. And this paved way to the development of impact and risk calculation. So example of a map or a risk map here is from Pag-asa. And this shows us the barangay building damage cost. So ito po ay na produce or na generate between 2012 and 2014, and this was instrumental. This GMMA RAP project was instrumental for the partnerships that we have with the LGUs, at least for the exposure database. No? Even the exposure database module was formulated to this. And it was this time that the LGUs, or some LGUs, realized the importance of developing their own exposure databases. Okay. It was also in 2012 to 2014 that we did detailed active fault mapping along the Valley Fault system, and it's very instrumental to the different platforms that we now have in GRIS PH also. So here we see the researchers conducting active fault peer reviews as well as field validation, and we've reflected those information on 1:5,000 scale maps. In 2014, under the DOST funded Science for Safer Community, we also disseminated different hazard maps for all regions in the country. And some of those information include scenario-based ground shaking models and maps, even results from previous mapping activities like RENA or READY project, even internal projects of different government agencies. No, during this time, we delivered to the different LGUs nationwide. So this is a picture of Yusek Suludum back in 2014 when we went from Luzon to Mindanao to distribute and as well as give lectures on the hazard mapping conducted in previous years. Then, in 2015, we released the Valley Fault System Atlas. It was the first of its kind, and here we published the refined version of the Valley Fault System, and because of that, information requests about active faults, not just here in Metro Manila and the adjacent provinces, no, surged. So from Luzon to Mindanao, there were actually a lot of requests for active faults. So that's why in 2016 we released the PVOLTS Fault Finder. It was through this, no, that we were able to give information to the public in a faster manner. This was developed with the GSJ, specifically with Dr. Joel Bandibas, who's shown here. And this is from the GSJ and our bosses here in PVOLTS. Now, this is the launch of um, the, the PVOLTS Fault Finder, wherein you just double click a point on the map, and then it will show you the distance, no, of that particular area from the fault. So this is a very simple interface wherein we um, put here the PVOLTS Fault Finder for the Valley Fault System. and as well as for other fault system in the Philippines. So from then on, there were actually requests to also include other hazards because fault finder, as the name goes, it's for geological faults only. So in 2017, another training was conducted by CCOP, or the Coordinating Committee for Geoscience Programs. And here again, we met DOST TVOLS, CAG-ASA, MGB, NAMRIA, and OCD. And as a result of the training, we agreed to standardize all the geospatial information and create a database system such that we can input or we can contribute the works from our different agencies, and then allow stakeholders also to access those information. So from then, we agreed that we will be proposing or submitting a proposal the following year for funding, just really to upscale the standardization of the information. And this was when we um, asked DOST, for funding for the GeoRisk Philippines initiative. And here, DOST PVOLS led that multi-agency initiative again with the following agencies: PAG-ASA, the NGB, OCD, NAMRIA, and we asked the help of our sister agency, DOST ASTI, not to host the different information in their servers. And then, of course, we have the funding agency and the agency monitoring the entire project. So at first, it was a project. It should have been 2 years, no? 2018 hanggang 2020, July, matatapos na sana. But then we extended. But since we have been collaborating, and as well as we have also presented this to the government, then it has been institutionalized already. So in 2019, we presented this to the president and his cabinet. Actually, this is the actual picture of that scene. Um, Secretary De La Peña and Yusek Solidum presented the GeoRisk Philippines initiative and the Hazard Hunter Philippines to them, and as a result, a directive was released, and that directive says that all government agencies would use the platforms developed by GeoRisk Philippines for hazards and risk assessment. And there was also an encouragement for all government agencies to contribute data for vulnerability and exposure assessment. So this is the homepage of Hazard Hunter PH. And the agencies with a memorandum of agreement are here. This is not updated, but at least for hazards assessment, these are the agencies that contributed information and as well as committed to support the initiative. This was the launch. So even before launching the Hazard Hunter PH, there was already a approval and a marching order from Malacanang for agencies or for the government to use Hazard Hunter PH. So here, Yusek Solidum launched the Hazard Hunter Philippines, and we have here the PressCon along with other government agencies. And in November 2019, we also launched the GeoAnalytics PH. And here, we have first released the tsunami analytics for tsunami. In 2020, we also launched the GeoMapper PH, and shown here is a photo of the first virtual training workshop for GeoMapper PH, and we worked with the REDAS, now which is one of the initiatives of DOST PVOLS in developing the module for exposure database. So we have LGUs here, LGU representatives using GeoMapper PH for the development of their exposure database. So that's just a short timeline. I just chose some of the important milestones for us to develop the GRIS Philippines. So now let me introduce to you some of the things that um, LGUs and NGAs would need in the collection of information. So this one is GeoMapper page, and as I said earlier, this is governed by credentials, meaning you need to have username and password, and this is actually for free, no, for the local government needs to use. Also, last year, the we were tasked by the National Land Use Committee to lead in the development of the National Exposure Database, and it was also agreed in that meeting that um, platforms of GeoRisk Philippines would be used as official platforms for the development of that database. Okay, so these are just some of the information that you could actually input, no, in the database, and where you can also use GeoMapper PH: population, land use, no, lifeline utilities, critical facilities. Of course, the hazards are um, automatically put there as layers in the GeoMapper platform. So for the GeoMapper, you can use the information collected for CLUP, for DRR plans, and you can also use the said application for resource mapping. If you don't have a GIS system, then you can collaborate with us, and we can share with you credentials for use of GeoMapper PH. Um, Also, other assessment software like REDAS can use information collected via the GeoMapper PH, and that's already being done by different LGUs and by the and by the system itself. These are some of the information that can be collected. So, ito po yung exposure information. Vulnerability, we can customize, no, the layers so that vulnerability information critical as per LGU could be added in the database. And then vulnerability information also when it comes to structural designs. Now, this with this we are working with with the Civil Engineering Society of UP. Okay, and of course, scoping capacity information as well as critical facilities can be included in the database through GeoMapper PH. Okay, so the GeoMapper PH works like this. First, it of course exists as a web application, as a mobile application. It's important that we have this mobile application since this includes surveys or on-foot surveys where different enumerators need to go out of their offices and just have a picture of the buildings and maybe interview some of the residents, not to input information specifically for vulnerability, for example. But since we are in the pandemic, we can still populate the exposure database using GeoMapper by using the web application, and by this we have been um, training LGUs actually in the use of GeoMapper PH and in populating the exposure database even without doing field surveys, just using their laptops and just including or inputting their credentials in the web app. So during a disaster, like or during an event, earthquake or volcanic eruption or typhoons, we would really need a dashboard, or we would need a system that would be able to inform us. And we've done this last year, no? during the series of earthquakes in Cotabato. And we see here how the integrated system works. And it's very important for us to realize the value of integrating things, integrating the information. So we have here the active faults information from DOST vaults, and we have also overlain here the information from DepEd, as shown here by the blue icon with flags. And we also have here health facilities from DOH and um, some of the earthquake epicenters from DOST vault. So just at a glance, we are able to identify the critical facilities that may be affected, no, by the hazards. And specifically for the visualization capacity of the GeoMapper PH, we have here information taken from the SITREP, no, of the NDRIMC or OCD, showing us the total amount that was um, received by the LGU per municipality. So we have the graphs here and we have the map. And if you're a decision maker, you would really find these tools helpful. At least for us here in DOSCP Vaults, we would want to have a bird's eye view of what's happening on the ground during volcanic eruption or earthquake or as an effect of a typhoon, for example, Lahar. No, so we usually deploy survey forms so that we would be able to collect photos from the citizens. And since people are already posting information and photos or videos of um, specific situation on the ground during events on Facebook, so we've thought that it would be good for us to also collect those information, but really for to encourage also the citizens to contribute, those information so that we could plot those maps in an integrated system or in an integrated dashboard. So we have here a dashboard for the effects of the Al volcano eruption in 2020, and we have here information from DSWD. Okay, and we see here affected families and the distribution of displaced families per municipalities. This is based on DSWD report. But imagine if you as LGUs have access to the GeoMapper PH and you have already populated the exposure database before an event happens, and you can report specific situation on the ground during a disaster, then it would be a lot more easier, for everyone to be able to assess the situation on the ground, and as well as um, make decisions, informed decisions for that matter. We've made the prototype of how the situation data mapper may also be optimized during a passage of typhoon. And since we already have information, not just of hazards information, but as well as exposure information like critical facilities or schools from DepEd itself, then we experimented on this and made a proof of concept or a POC. For example, for a passage of typhoon, of a particular typhoon, we've plotted here the layer, no, school layer, and then the passage of the typhoon, no, and then we see here that the figures change as the eye of the typhoon moves northward. So, kita niyo po yan. And the graphs also change. So, you would see here that this is, at this point of time, the typhoon is in Albay and Eastern Samar, and the number of schools that may be affected is shown here in this graph. So, as the typhoon moves upward or northward, then the figures also change, and also the number of schools here also change. And then as it goes north, again, the names of the schools here or the provinces are changed as well as the figures. So this is the beauty of having an integrated system and having the um, government work together through GRIS Philippines. So again, the National Exposure Database, this we will develop, and this we can do only through the help of the local government units also. And we would really want to empower the local government units in developing their own exposure database. And this database will not be point driven, but it's really more of a polygon. That's why we also need the data from remote sensing so that we will be able to populate the database with polygons already. So from GMapper PH, from collection of information, we need analysis. And here comes the geoanalytics PH. We can get summary hazard assessment reports through geoanalytics PH, and this is being improved to include information from GeoMapper page. But for now, since it's for public, then I will show you how it works now. So if you would want to reference the information that you will be gathering from GeoAnalytics page, you can just click this data and methods used, and you will be able to get the formula as well as the sources of the information and cite accordingly. And if you would also want the hazard maps from the different government agencies, then you can actually click this link here, official hazard maps, and you will be directed to the hazard maps. So you just need to go to geoanalytics, the georisk.gov.ph to access the power, the computing ability of geoanalytics PH, and as well as the information from the different government agencies. Okay, so this is an example of a result of a map showing us the um, tsunami hazard map in a particular barangay in Davao Oriental. So this is Barangay Central Mati, Davao Oriental, and it shows here, based on the computation made by Geoanalytics, that 1.7 square meter or 16% of the land area is prone to tsunami. So we have here the specific result. And then if you would also want the specific information as to hazard susceptibility, you will be able to get that. So this is in square meters. And so um, this would constitute, sorry, I'm distracted with the pop-ups. Okay, so this is assessment, and then this is the land area in square meters. So the users of Geoanalytics PH can actually generate their own hazard maps. So this one, and it's specifically cut according to the barangay or municipality or province. And then you could get the chart and as well as tables. So this, for example, is the land area analysis using Geoanalytics PH for Batangas. If you choose volcanic hazards and if you choose Batangas province, this will automatically show. So this green polygon here would show us the boundary of Batangas. And then here is the hazard. So these are yung orange at saka yellow are hazards information, specifically base surge. And then the dark rings here would represent the kilometers from the crater. So when you do this analysis, you will automatically get charts and tables and the list of the barangays that may be affected by a particular hazard. and there is already a chart, no, that would show us the number of people that would be affected by specific hazards. And not just that, but we also have the age and sex disaggregated data, wherein you would see here the population, either male or female. So that would comprise the total. Ito pong lahat, pink. And then the dark pink would represent here the population, female population prone to a specific hazard. Okay, so if you would zoom that, we would really be getting very detailed information that you may use in your various plans or various initiatives. Okay, for example, the application will already tell you the total number of population that is prone to specific hazard, and then it will also already tell you the total number of people in an LGU and the percentage that is prone to that particular hazard. So there's also a summary report that you can click for you to get a more detailed analysis. For hospitals and schools, there's also an analysis for that. You just need to click the health facilities or the exposure information that you want analyzed using the platform, and then we would see here already the list of those that may be inundated or that are inundated by um, the tsunami hazards in that particular area. In this case, Pagadian City. Okay, so that's it for this is summary for Geoanalytics PH. Let me now transition to the Hazard Hunter PH. Okay, so Hazard Hunter PH has a tagline, and it's called Hazard Assessment at Your Fingertips, because we really want to make hazards information available to everyone, and that everyone may access this efficiently and accurately, since these are the information come from the different government agencies. So we would want people, everyone, institutions, even, to be aware of natural hazards. So you can treat Hazard Hunter PH as a one-stop shop for hazard assessment. You can also treat it as an online consultant, no, online hazard doctor. If you would want, you would want to know, for example, if the place or the house that you're living in or where you are now, no, if you want to know the hazard assessment for that particular area, then you can consult Hazard Hunter PH, and it will automatically give you the assessment and the summary report, as well as recommendations from your government. It is also an on-the-go GIS specialist. So if you're having a hard time consolidating all the hazards information, you can have the Hazard Hunter PH help you do that, because you can just overlay all those information on the map, and you can screen grab, and as well as get the analysis as being shown you in the hazard assessment report. And since we have information from government agencies, we can be assured that the information here are reliable. And since this is online, it is for free also. It is available 24/7. Okay? So dahil online siya, as long as you have internet, no, you can avail of the services of Hazard Hunter PH. Now let me show you how you could use or optimize the benefits of Hazard Hunter PH. First, you can go to hazardhunter.grisk.gov.ph, or you can simply go to your browser and type Hazard Hunter, one word, or Hazard Space Hunter. And the first item that will be shown you would be the website of the Hazard Hunter PH. You just need to click that. And then when you click that, you will be directed to the home page of the Hazard Hunter PH, and it will give you instantly, no, options on how to um, search a particular location. So the first option is for you to type. Everyone may be very familiar with this since everyone, I think, already uses Google Earth. So you just need to type the location for hazard assessment. Or if you're using your mobile and you have turned on the GPS of that mobile phone, you can automatically click use current location tab. Okay, and the platform will automatically assess that particular point. So the accuracy of this would depend on the accuracy of your GPS. And then if you have the longitude and latitude of that particular area, you can use your use coordinate button. Okay, so you just input the longitude and latitude of that area, and then again, it will conduct the hazard assessment. Now, if you know specifically on the map where that particular area you're assessing is, then continue and just click go to map view. Okay. And then we have here some details and then all the government agencies and as well as an acknowledgement here in the homepage. So in the map view, again, you are given the option to just type in the location or just input the current location based on your GPS and then the longitude or latitude if you have the coordinates. And if you know exactly on the map where your location is, then you go to this option. Just zoom in and zoom out. Okay, let me just give you a run through of the options that you have here in the left panel of Hazard Hunter PH. There's this display option, and under display option, you will be given base map options. So if you click base map, you will be given opportunity to change your base maps depending on the um, information that you want highlighted. So you can choose satellite image by Google or OpenStreet or other SV base maps. And then if you click this hazards, then all the information from the agencies are already shown. So we have seismic information from DOST vaults. We have also volcanic information from DOST vaults. We have hydromet information from DNR, MGB, and Pag-asa. And then if you click exposure, you will be shown information from DepEd for elementary and secondary schools. We also have DPWH road networks. DPWH contributed primary roads and secondary roads. And they will soon be contributing additional information like bridges so that they can and also the public can conduct hazard assessment for those infrastructure. And then we also have DOH facilities. This is based on the information submitted by DOH. And we've added here PSA boundaries. Just recently, we added the coping capacity layer in Hazard Hunter PH. And this shows us the safe open spaces in the National Capital Region. This is very important for planning purposes and as well as for resource allocation, specifically for the LGUs as well, to maintain those safe open spaces. So this was, again, done through collaborations of the different agencies, specifically NAMRIA and PVOLTS, as well as the different LGUs. Okay, we also included here under the display options, a layer for advanced information, those information that may be desirable to engineers and other sectors. We will be adding additional layers here. So for example, for peak ground acceleration, spectral acceleration, structural engineers may be very interested on such kind of information. So if they want those, they can just click this advanced layers, and then they can click specific ground acceleration information or spectral acceleration information. Then we also have resources here under the display options. Mm, The resources would include earthquake and volcano monitoring, hazard assessment overview. You can also download hazard maps, and as well as some of the terms that are commonly used in the different interfaces of Hazard Hunter PH. Now, if you want to go to our other platforms, you just need to go here and then just click GeoAnalytics PH. Now, for GeoMapper PH, you need credentials for that, and we need to sign memorandum of agreement, since for GeoMapper PH, we need to ensure that the information contributed are verified by different data managers and as well as approved by the local government units to be included in the integrated system, because it's very important that the information contributed are accurate, since this will be used for analysis later. Okay, so these are just some of the items that you will see in the Hazard Hunter page interface. If you want to contact us, just click this. And again, at the right panel, you would see here this this icon. So you can explore. You can click that, and when you click that, you will again see here the different resources that we have. So if you want Earth to monitor earthquake and volcanoes, you can click this lens, and then for hazard assessment overview and for downloading maps. You can actually explore, and then you would see that there are a lot of features that have been added in the Hazard Hunter PH. Okay, now let me go to teach you how to conduct hazard assessment using the app. So, so again, I mentioned that you can input information or location information through 4 methods. So you just need to choose. If we choose, for example, the first one. So for example, if I want the House of Representatives assessed, it's the building that they have here in Quezon City. So you just need to type house, and then options will be shown you, and then you just need to click that particular place that you want assessed. And then the tool will enable you to zoom into that particular building. And what you need to do is just double click that building. So for example, I choose this building here. So if I choose that, I would wait for about 15 seconds. And after that, this pop-up will be shown. No, just click see result. And then the result will be given you. And this would just indicate the summary assessment from the different government agencies. So we have here from PVOLX, from this one also from PVOLX, and we also have here from MGB and Pag-asa. The dark blue line here would show us the distance from the West Valley Fault, since this is the nearest active fault, no, in the from this building, and this would also show the distance from Taal volcano. Okay, so this shows us that the nearest active fault is the West Valley Fault, and it is 1.1 kilometers. And because that is so, no, kasi 1.1 kilometers siya. Against ground rupture, the building is safe, because our recommendation against ground rupture is at least 5 meters from the active fault. So since it's 1.1 kilometers, it's very far already from the fault. So the ground rupture assessment is safe. Then for ground shaking for that particular building, it is prone to intensity 8 earthquake should the West Valley Fault um, move and generate a particular magnitude. We have also included here a link for individuals, no, or families to be able to assess if their houses are indeed safe from ground shaking. So you just need to click that portion there, and the safe And the tool entitled "How Safe Is My House" will appear, and then you will need to rate if the building indeed that you are living in is safe or not. And then there are other information and assessment coming from the DOST PVOL, so for earthquake-induced landslide, liquefaction, tsunami. So these are the assessment results. And then what's the nearest active fault, and as well as different volcanic hazards. We've also added here hydrometeorological hazard assessment. So for rain-induced landslide, for storm surge, and severe wind, the assessments are already shown here. And if you want information on the the meaning or the definition, or why, why the method, why the said assessment was given you by the government agencies, then we also have a more comprehensive result for those inquiries. So for nearest critical facilities, we have also included here. Nearest critical facilities are schools, elementary school, secondary school, and the health facilities, as well as DPWH information. Okay, so if you click this view report with recommendations, you will be shown a very comprehensive report from the agency. So you will see the logos here of the agencies, and then the date when the assessment was conducted, and then the coordinates that was used. And then here we see the hazard that is being assessed, and the assessment itself, and the explanation, and the recommendation. So lahat po yan nandiyan na po. And of course, we just put here a note or a disclaimer that it is based on the input of the user. So for seismic hazard assessment and hazard assessment report, we have these explanations and recommendations. So we also have recommendations for volcanic hazard assessment, and as well as for hydromet. And this now comes from the Mines and Geosciences Bureau. And also here, we also have hydromet assessment for storm surge and severe wind. And this comes from the from Pag-asa. So if you notice, we have here QR code. So if you just scan that QR code, you will be directed again to the assessment or the coordinate. So this one. So you will be directed, and then the information again will be shown you. Hazard assessment. And this one also, this is at the last page of the comprehensive hazard assessment report. It shows us the distance from critical facilities. Okay, so here's an example of a detailed hazard information. This is tsunami, wherein we've included here 6 inundation colors to show us the meters, per gradation. And so if you want to highlight the colors, you can, of course, choose from the different base maps. And depending on the feature that you want highlighted, then you can change base maps. And then if you would also want to add the barangay boundaries, or municipal boundaries, or provincial or regional boundaries, if you want to know the name of the barangay, then you just need to click this exposure, and then go to boundary PSA, and then click barangay, for example, if you want barangay, and then you click that particular polygon, and this will be shown. So region, province. So this is barangay Banao, this one. And then of course, if you would want to see the health facilities in the area, or the health facilities that are prone to a specific hazard, in this case tsunami, you just turn on government owned and privately owned, and then all the information will be shown you. So how do you conduct volcanic hazard assessment? So again, you just go to the site, and then go to map view, then click this hazard assessment overview. When you click that, you will be directed to this panel. Just click volcanic. After you click volcanic, choose a particular volcano. So in this example, we have Mayon volcano. And I want to assess Lahar. So I click Lahar. And then immediately the hazard information will be shown you on the map. If you click that, then immediately the elements prone to lahar from Mayon will be shown you. So example, population, how many people will be affected. So it's 407,000. And then the name of barangays also will be given you in a separate report. So here we see barangays 248, elementary schools 148, secondary schools, government health facilities, and private health facilities. And then if you click view full report, then you will be able to get the comprehensive result. Now, if you just need to download the CSV or the Excel file, you just need to click this button here. And then you can view or unview the particular layer. So, for example, if you don't want to see the barangay, you just click the barangay boundaries. You just click this barangay boundary, and the barangay boundaries will be removed. Similarly, if you remove schools, you just need to click the icon of the interface. This is the CSV list, no, of the barangays prone to lahar in Mayon. This is the PDF report of the assessment. So you will be given here a list of the barangays affected. So medyo mahaba po yan. And then also the different exposure information. Now, if you want to download hazard maps, you just need to, okay, click this, download map. And then when you click that portion, or when you click this icon here, you will be directed to this interface. So you will be given option to choose, no, kung anong region, province, or municipality. So depending on the availability of the map layout, then it will be shown you in this portion of the interface. So for example, I want municipal scale maps of um, Albay, no, hazard maps for Albay. So I click Region 5, and then Albay, and then municipality and city. And then if these scales are available, then all this information, no, yung mga map layouts would be shown you. And then you just need to click that. When you click that, you will be directed to the individual map layout for hazard. So this one, for example, yung province of Albay, then we have here active faults in Albay. So you would see here that Albay is highlighted. And then if you would want also tsunami hazard maps, those are also already available using the download button of Hazard Hunter PH. Again, for volcanic hazard maps. Now for Region 4A, we also have, I just was not able to prepare that, but this is for Mayon. But similarly, you can access the similar manner, no, of accessing the information for map layouts. How do you determine also the volcano alert level status using Hazard Hunter page? You can also do that. Go to the map view, and then you click here, earthquake and volcano monitoring. And then you would see here the status of volcanoes, yung mga active volcanoes that we're monitoring closely. So for example, the name of the volcano will be shown here, and then the alert level and the date that the said alert level was announced. And then if you click this particular blue text, you will be directed to the official volcano bulletin, We can also do near real-time earthquake monitoring using Hazard Hunter PH. Um, Here is an example of a compilation of earthquakes in a particular area for the month of September. So it's from September 1 to September 30, all magnitude and all depth here in this area. So how do you do that? You go to the earthquake and volcano monitoring portion, and then you click earthquake. Then as a warning, kapag clinic nyo po tong earthquake and volcano monitoring, it will alarm should there be an earthquake, no? And if you're in a meeting, baka magulat po kayo. So you can actually have that option to turn off the alarm, the alert. So you just turn that off. And then you can choose already the day, no, or yung date range that you want to monitor or to see. So for example, September 2020, and then you just click here, September 1, the first click would be the first day, and then the second click would be the end date that you want to see. And then we have here the legend. So for this particular query, we see the different colored dots. These dots would represent the earthquake plots, location of earthquake plots, and as well as the magnitude, no, yung gano'n siya kalaki or kaliit. And then the depth, this would show us the depth where the earthquake was plotted. Then if you want to query just magnitude 5 above earthquakes, then you can do that. Also, if you want to query specific depths, especially for us researchers, you want to just filter 0 to 3 kilometers, for example, then you can do that. But here, we choose all the earthquake plots. So you can do that and just click all. And then there will also be a total earthquake count for that whole month. And there's a summary here. So ito na po yung 1,061 daw earthquakes were recorded in September 2020. Then you also have an option to display or not display the results. Okay, so this one is, yeah, the legend is very important so that you would know. And then here, this blinking dot here would mean that that's the latest earthquake based on the plottings of PVOTs. If you click a particular dot, no, or a particular earthquake plot, then this pop-up will show. So what you need to do is just click more information so that you will be directed to the official earthquake bulletin. That's from PVOTs. Okay, let me show you how the integrated system works and how this can be used, for example, in your planning activities and your decision making. So since we already have the information from the different government agencies and as well as earthquake plottings, for example, from PVOLs for monitoring of earthquakes, then even during an event, no, you would be able to plot the earthquake generator, meaning the active faults, no, on the map, and then also overlay the earthquake plots, and then also you would see the location of active volcanoes. And then since we already have hazards information, for example, if you want to know specifically where might the liquefaction happen, no? Or possible liquefaction happen during an earthquake, no? Then you can just turn on the liquefaction layer, and then this layer here will be shown you. And of course, if you would also want to know the location of schools and location of health facilities, then you can also do that. And again, for engineers, no, yung mga peak ground acceleration for calculations, You can use the Hazard Hunter PH to do that. And the beauty of this is that you would also be able to see the earthquake sources, where the computation was actually based on. So here, for example, in Cebu City, we know that this was the basis for the calculation of the spectral acceleration. So let me show you the recent addition in the Hazard Hunter PH, how it looks like, and maybe you can also consider um, doing this, in your localities. This is just for Metro Manila. So this is under the coping capacity layer in the Hazard Hunter PH. So what I want to see are safe open spaces in Metro Manila and NCR. So I would want to see the boundaries of NCR and other provinces. So I would just go to exposure and then just turn on PSA boundary and just turn on region or province. After that, click the coping capacity and then click save open spaces. And then we will be shown here polygons. No? Ito yung mga dark polygons na red. And this would show us the availability of safe open spaces in particular LGUs. So for example, in Taguig, the safe open spaces here would be these portions. Okay, this is for Taguig. And how about for other LGUs? Then they will have to decide what to do if they don't have enough safe open spaces. So these are the tools that we have right now under coping capacity. And we hope that this will really serve the purpose for the LGUs to be able to um, develop their plans, for DRR, plans that are really evidence based and science based, and that they will not have so much difficulty in getting all this information, and as well as the calculating capacity of the tools. We can really maximize this. um as a way forward, we would also want to report under coping capacity the different initiatives by the local government units in terms of mitigation, for example, tsunami mitigation, or how many evacuation centers are safe, or where are these located, or other efforts that the LGUs have already done, so that at the national level we would be able to assess the capacity of the LGUs in terms of their preparedness to specific natural hazards. So again, ladies and gentlemen, the platforms of GeoRisk Philippines are the following. For data collection, we have GeoMapper PH. For analysis, we have the GeoAnalytics PH and the Hazard Hunter PH. The GeoAnalytics PH may be used for summary assessment reports, and the LGUs can really take advantage of the computing power of GeoAnalytics PH in their various plans. And then for the Hazard Hunter PH, this is available, and this is really applicable and useful for even individuals and LGUs, as well as the national government. So from here on, like what we did in the national level, now where we collaborated with each other, we led that, the different government agencies like PVOLS, PAG-ASA, NGB, OCD, and DAMRIA. We worked together, and we put our efforts together, and the work's done, and now we have here the integrated system. And because other agencies saw the benefit of working together, then we are having more agencies really collaborating through the GeoRisk Philippines. So again, GeoRisk Philippines may be considered as physical platform where we develop tools and methods and web or mobile applications for integration of the different information, but also it can also be considered as a governance platform. Okay, so where we can collaborate and we can talk to each other. So there, ladies and gentlemen, is the GRIS Philippines initiative and the different platforms. Thank you so much.
Thank you very much, Miss Mabeline, for your very technical and relevant presentation on the GeoRisk Philippines. Ang ganda po talaga nitong GeoRisk kasi ang daming features, pati yung databases na pwedeng gamitin depende sa needs ng mga interested bodies or persons. Grabe yung ilang years po ba yun? 15 years siyang pinaghirapan. So I hope na mas strengthen pa po ang collaborative efforts ng mga mapping agencies to be able to provide more relevant and authoritative data na mas helpful for the decision-making of our local and national leaders.
Actually
Now
po,
we are
15 years.
sorry.
Kasi meron pang mga other information no na before 2005 na nakalagay pa rin doon. So it's really a good initiative by the different government agencies and those collaborative efforts ng mga iba't ibang ahensya ay talagang nakakatulong.
Ayun, thank you po, ma'am. Now we are opening our room for questions, but due to our time constraints, we apologize in advance if we have to limit our questions to, I guess, 5 questions. So from Facebook Live earlier, Miss Geraldine Santos has 2 questions for Sir Roel. First is, how long does one hazard map using AI technology take for one LGU? And the second one is, can the AI do the mapping for the whole Philippines for the preparation of DRRM plans of LGUs? Sir Roel?
So dun sa question po na, sorry.
Hello. Regarding dun sa how long dun sa hazard, I think si Miss Mabi yung makakasagot doon. For the hazard, I'm not sure yet kung paano siya gawin sa AI, but if you have training data, we can train it to do so. So, I reserve that na sagutin ni Miss Mabi mamaya. Dun sa DRRM plan, how long sa buong Philippines? May stats kami yan before using yung land cover. I think hindi naman abutin ng weeks. Few hundred hours yung kailangan para ma-delineate yung buong Pilipinas. Ang maglilimit sa'yo dyan is yung availability ng satellite imagery. Kung very high resolution, that's very expensive. It will take you hundreds of millions of pesos sa cost. Pero kung free satellite image like Sentinel images or Landsat, we can do 180 hours yata kung tama yung pagkakatanda ko. So, kailangan ding malaman kung ano exactly yung mga features na i-delineate. Kung DRRM plan, ano-ano ba yung mga yon? Maybe we can say what specific features need to be delineated, tapos yun yung i-train na para ma-detect, and then after that, a few minutes na lang siguro. Yung 180 hours or na sinasabi ko kanina, I'm not sure. I think slower pa. Teka lang para na yun sa full na land cover from Landsat. So marami na yun. I think 4 or 5 na yun na types of land cover. So mabilis lang siya. Ang matagal dito talaga is yung pag-train. Kasi you have to create so many training data. So kung meron kang 10 features na gustong i-detect from a satellite image, then you need to make thousands of samples, okay, per feature. Tapos i-fine tune mo pa yon, kasi kung garbage in yung ipasok mo, mas mahirap niyang matutunan yon. Kung nakakalito yung training data na ginamit mo, malilito din yung tinuturuan mo. So hindi rin maging maganda yung detection niya later on. So nandun kaya yung collaborations namin, mostly ang focus talaga namin is how to create a good training data. So, ayun. So, I hope I answered yung question. So, si Miss Mabi na lang siguro sumagot dun sa hazard thing. Thank you.
Thank you, Sir Roel. Sige po, Miss Mabi, you may answer the question po.
Ano yung hazard map? Ano yung tanong po?
How
long?
long does one hazard map using AI technology take for 1 LG? I think ang question po is gaano katagal po siyang na-generate for 1 LG?
Depending on the number of people working on the information, actually we can do desktop mapping for the whole Philippines, but we really need to validate also on the ground because for example, yung mga RS data natin needs calibration as what Sir Rodel also mentioned earlier. We need training data, diba? So we need to calibrate the information for us to be able to do AI. And right now, we already have information on that. So, yun po.
Update na ako sa sana.
So, depending on the mapping scale that we need, depending on the availability of the data. So, marami pong requirements or maraming components that would determine the length or the duration by which a particular hazard map can be produced. So yung based on the availability of information and the grade or yung scale, no? Doon din po magbabase yung accuracy nung hazard map na mapoproduce natin.
Ayun. Thank you, Miss Mabi and Sir Roel. I hope na sagot po yung tanong niyo, Miss Geraldine Santos. Okay, our next question is from Sir Roel to Miss Mabeline. How did you generate the safe open spaces? What are the criteria? Miss Mabi?
Okay. So it was Namria that generated the safe open spaces, and the results were validated by the LGUs. So ano lang po siya, model builder.
Mabi with
First
hazard assessment yun.
Yeah,
With
yes
hazard
po. Yung
assessment.
nag-hazard assessment, yung earthquake hazard assessment, and then for the GIS capacity, model builder po yung ginamit nila.
Okay po, thank you po, Miss Mabi. Before I proceed to the next question, allow me to read some of our chat messages. So from DOST Fivox, Montes, Ange, the building typology embedded in the GeoMapper is from civil engineers. It is also used in REDAS. And from Fivox OD, what is being produced by ASTI is not hazard map, but an impact map like flooded areas, landslide affected areas. Hazard mapping is done using remote sensing, modeling, and ground mapping. If you have any more questions po, our chat is still available. Yung isang staff po namin, may question po. Sabi po ay pumunta lang sa website. So free daw po ba ang GeoRisk for LGUs? Miss Mabi?
Yes.
Okay po. Meron pa po bang mga katanungan sa ating mga resource speakers? If you have any more questions, then you can message our Facebook page or email us, and then we will relay to our resource speakers and we will get back to you. Also, may I remind everyone, our participants, to accomplish our event evaluation form to be able to obtain their certificate of participation to this webinar. Now, may we award this virtual certificate of appreciation to our esteemed speakers for their time and efforts and imparting their knowledge to us. The certificate citation reads, Certificate of appreciation is awarded to Engineer Roel M. De La Cruz as keynote speaker during the Center for Hazard and Environmental Resource Mapping CHERM webinar on appreciation of disaster risk reduction and management, DRRM maps, as part of DOST Calabarzon's pre-NSTW activities with the theme Agham at Teknolohiya, Sandigan ng Kalusugan, Kabuhayan, Kaayusan at Kinabukasan, held on the 11th of November 2020 via Zoom and Facebook Live. Issued this 11th of November 2020 at Los Baños, Laguna. Signed, Dr. Alexander R. Madrigal, CESO 2, Regional Director of DOST Calabarzon. Our same certificate is awarded to Ms. Mabeline T. Kahulugan, issued this 11th of November 2020. Once again, thank you very much, Sir Roel and Ma'am Mabeline. Our staff will keep in touch with you for your tokens of appreciation. And again, for our participants, kindly complete the evaluation form for your certificate of participation. Thank you very much.
Thank you, everyone. Thank you very
To
much.
finally close our CHERM activities for today, let us welcome the Provincial Director of the Provincial Science and Technology Center, Quezon Province, Ms. Maria Esperanza E. Hawili, for the closing remarks. Ma'am Hawili. Ma'am Hawili, naka-mute po kayo, ma'am.
Sorry, mahaba na yung nasabi ko. Anyway, so good afternoon to everyone, to our guests, ang ating resource persons, ang ating mga stakeholders, no, at saka ang ating mga participants. As we celebrate the 2020 National Science and Technology Week this November 23 to 29, 2020, the DOS Calabarzon has lined up and organized various pre-NSTW activities to showcase the agency's programs and services. So one of the projects that was collaborated with the DOS Calabarzon office and the Southern Luzon State University is the establishment of CHERM, o yung ating Center for Hazard and Environmental Resource Mapping. And the CHERM laboratory is located at the second floor of our DOST Quezon building here in Lucena City, in Quezon. So for your hazard mapping needs, you're welcome to visit us. Online siguro muna. For special requests, siguro you can go visit us on site. And earlier this morning, we launched the CHERM institutional AVP and the virtual tour of the CHERM laboratory. I guess those who came in earlier, nakita nyo yung short video about CHERM. And early this morning also, the ceremonial turnover of the layered maps to the LGUs affected by Taalas was conducted. Now, this layering of maps provided by CHERM is just one of the products of the laboratory or services offered by the laboratory. Now, I hope may mga na pick up kayo mga points at saka knowledge doon sa webinar on appreciation for DRM maps. And we hope that we can gather potential partners dito sa ating mga services for the CHERM laboratory. We hope our LGUs, ating state universities, national agencies, and other stakeholders can partner with us in the implementation for this CHERM laboratory. Now, this activity is just one step for a strong partnership towards progressive vision. And we hope that to see you in the future dito sa ating SHRM sa DOST Quezon. No? And we also hope you join us, the DOST family and the science and technology community, in all our activities for the 2020 National Science Week. Alam ko, konti ang nag-inquire o nagkaroon ng questions. Alam ko, karamihan ng participants natin ay mga DRRMO. Kayo ba ay balisa na para sa inyong mga trabaho sa darating na bagyo? So, hindi ko na pakakatagalin. Sana medyo nahabaan natin yung mga discussions on the topics. But there is an impending typhoon na daan dito sa amin sa Quezon. And we hope and pray na less yung maging hazard, damages, no casualties sa pagdating ni Ulysses. So, thank you very much for attending the webinar this afternoon. And everyone, please stay safe. Good afternoon.
Thank you very much, PD Hawili, for your message.